Question 1. So to find the speed of Q immediately before the second collision, let's consider the second collision between Q and R. So what do we know about this collision? We know that prior to the collision, Q has got a mass of 0.3, but we don't know the speed it's travelling at. This is obviously the speed it was travelling at before the first collision. We need the speed before the second collision. So what we know that R, its speed before the collision was 0.8, because that wasn't involved in the first collision, and we're told that, we obviously know the masses of Q and R, and we know the speed of Q and R after the collision are both at both 1. So using the conservation of momentum, so mv plus mv equals mv plus mv, so before and after, we're just substituting in, we can work out that the speed of Q, before the second collision is 1.4 meters per second. Now for part 2, calculate the change in momentum of P in the first collision. So change of momentum is mass times change of speed. So we know the speed of P before the first collision was 1.5. So in order to answer this, we're going to need to know the speed of P after the first collision. So we know the speed of Q after the first collision from what we've just worked out in part 1. So substituting in, so our momentum's before the first collision. For P it's 0.1 times 1.5. For Q it's 0.3 times 1.1. We don't know the speed of P after the collision yet. We do know the speed of Q after the first collision. We're just using that from part 1. So our only unknown is the speed of P after the first collision, so we can work that out to be 0.6. So then change of momentum is m times the change in speed. So the speed has gone from 1.5 before the first collision to 0.6 after the first collision. Timesing this by the mass of 0.1, we get a minus 0.09. We're being asked just for the change in momentum, so just give the positive value, 0.09 kilogram meters per second.